Hi, this is Aditya, and here we're going to discuss about embedded packet capture. So, packet capture is a feature of Cisco iOS, where using this feature we can capture the packet out any interface in both direction, either ingress traffic or outgress traffic. So suppose if you running any emulator software like GNS, you can just right click on particular interface, and then after you can able to capture the packet on that interface. So if you have a physical Cisco box or physical Cisco device, you cannot right click on physical links, and then after you can able to capture the traffic. Somehow you have to have go through some configuration, so that is what known as embedded packet capture. So make sure your operating system going to support embedded packet capture. So this is the feature is available from 12.4T iOS. So the configuration is a little bit straightforward. I find that what you need to know if you going to enable embedded packet capture. So in embedded packet capture, they're going to use your hardware, means CPU. So if you're running your router and you want to sniff or capture the packet, your CPU is going to use of your router, your RAM, obviously, and somewhere you want to export that packets. So whatever packets so you have captured, you want to export for analysis, you want to diagnose traffic, you want to verify the connectivity, you want to know the behavior of protocol. In such case, we can use the packet capturing on particular interface. So what is the benefit of EPC or embedded packet capture? You can capture the traffic which is IPv4, IPv6, and then after you can analyze, you can figure out what is going behind the scene. So let discuss a little bit more about the packet capture. So in packet capture, there is three initial command we need to do. Your first command, we need to create a capture buffer. A capture buffer is a temporary memory of RAM where you want to allocate to store temporary your packets. So first we need to specify the amount of memory which we going to allocate for buffering the holding the capture packets. The next thing what we need to do, we also need to specify where we want to capture the packet. So suppose if you have a router, you may have a tons of interface on which interface you like to capture the packet, and then after you're going to export to the a particular machine so that you can analyze the traffic details, source, destination, and whatever you want actually. The next thing what we need to do, we need to associate a capture point to the capture buffer. Since you can create multiple capture buffer, you can also create multiple capture point. So now you need to define on which buffer, which kind of capture point you want to associate with. So suppose if you selected a capture interface gig 0/0, and you want to put that capture data on, suppose that capture buffer text. So better to understand, we'll go through the configuration. So configuration is straightforward. One more thing which we need to understand, this is not going to happen on globally. You need to execute command on privilege mode. So monitor, capture, and then after buffer, and the name of buffer, where we can specify the size of buffer, minimum and maximum size. If you're not going to specify, there is some default value is allocated. The next step is the creating a capture point. So CEF is doesn't means you're going to the capture CEF or Cisco Express Forwarding Packet only. It means basically you're going to enable the name, you're going to enable a point where you want to capture the packet. So this is the name of point where we want to enable packet capture. Your packet capture could be uh, in one direction like in or out, and then you need to specify the interface. And finally, what we need to do, we need to associate them. So monitor capture point and associate, this is the capture point and this is the buffer area where we want to store data. Now we need to start the capture, and once you start the capture, we also need to stop the capture after a specific time. So let me go through the configuration. This is my topology where I'm going to use the capture. So I have a branch router and HQ router. These are 2901 and running iOS 15.0. So this is my laptop where I'm recording my video, as well as I have a TFTP server. So I'm going to capture traffic which is moving from branch router to HQ router of serial interface, and then after I'm going to export it to my laptop where I am running TFTP server. So actually my device is up and working, and let me do the practical, or let me go through the CLI. This is my console window. Let me bring my console window and my terminal server. Yeah, and then this is my terminal server where, excuse me, hopefully this is right credentials. Oh. And this is actually, yes, there we go. And the next two step is I'm going to select my branch router and HQ router. So this is my branch router and another is my HQ router. On branch router, what I'm going to do, selecting interface gig0/0 IP address get from the DHCP server, and the next is my serial interface IP address 1.1.1.1 255.255.255.252, no shutdown. Similarly, on interface, serial interface of headquarter router 255.255.252, no shutdown. So now branch router should have connectivity to my laptop as well as headquarters. So let ping to my laptop. My laptop IP address is 192.168.1.100, and there we go. We can see we do have a connectivity to the TFTP server. The next step, what I'm going to do, check the connectivity to headquarters. As we can see, we do have a connectivity as well. So finally, I'm going to enable packet capture. So this is my configuration example which I grabbed from the CISCO. So let me go through the configuration. Monitor and monitor capture a buffer, and name of the buffer. In my case, I would like to keep the name is test, and then after you can specify the size. So let me use size which is 500. If we want to show this buffer, we can use command show monitor buffer, excuse me, so monitor, then after capture buffer and name of buffer. In my case, I'm going to see the all parameters. Then we can see we have created a capture point, a capture buffer. The name of buffer is test, and this is the memory which we have allocated. So far we do not have a capture any packet. So the next step, what I need to do is specify the point where we want to capture the packet. In my case, monitor packet capture buffer, and then, excuse me, monitor packet capture, then point where we want to capture the packet. This is IP. You can specify. I like for IPv6 or something else. In my case, I'm going to use IP, and then after CEF, whatever is performed by CEF, and then name of capture point. In my case, cap. And we also need to specify on which interface we like to capture the packet, and as well as the direction. In my case, I'm going to use both. So now we created a capture point as well as the capture buffer. The last thing what we need to do, we need to associate them. So monitor capture, and then after monitor capture point, and then point we want to associate with, this is the actually capture point. The capture point name was cap. So this is cap, and we want to put it buffer of test, which we have created, I think, already. Let me verify that. I think the name was test. Yes. Anything else? No. The next start monitor capture point, and the name of the point. It was, sorry, monitor capture point start now. Start all, or the particular name which we have created. So the capturing is ongoing, and let me send some packet from headquarter to the branch. So 1.1.1.1. These traffic actually sent from headquarter to branch. Now this is time to stop capturing and export those capture file to my laptop, where I'm running TFTP server, as well as a tool which is known as Wireshark, in order to see the detailed protocol, the protocol detail. So now the next command going to be stop. Sorry, this is need to be execute on here. Stop all, and there we go. We can also see, so monitor capture, and then after buffer. In my case, I'm going to see all those buffer, and along with the parameters. So we have a 10 packets. That's great. Monitor capture buffer. The name of buffer was test, and then we want to export it to the TFTP server. So before exporting TFTP, make sure you have turned on your TFTP. So let me enable my TFTP server. Actually, let me turn on TFTP, which I have already installed a program, and I'm going to use this on interface 192.168. And I want to put those, the directory is desktop. So before sending, I think we do have a connectivity actually. This is 192.168.1.100, and the name will be let me see, sample.cap. So we can see it successfully sent it to me, and we have that file. Now we can click on it. So we also have some sorts of program which allow to see those raw packets capturing. So now we can see the all about, it was the ICMP packet, the source address, destination address, and all those things. So this is all about this tutorial.